Hello and welcome back. This video will be on section 2.3, which is on graphs, more graphs than just the histogram. So we'll just cover a lot of different graphs in this video. The first one is the dot plot. This is a graph that displays quantitative data, and essentially it looks like a bunch of dots. So I apologize for my drawing of some of these graphs, but essentially in a dot plot, every data point will be represented by a dot. And when there are more than one data points that have the same value, we start to stack them. So for instance, 10 here, we count 1, 2, 3, 4, 5, 6 dots above 10. So it means that the number 10 occurred 6 times within our data set. So I just made up some, say there's a game that people were playing, and this is just the number of points that they scored. One nice thing is that dot plots display a shape really well. We can sort of see that this is mostly uniform, but there are some dips in there. And you can also recover the original data from this plot really easily. So for instance, we know that the number 4 appeared once. So if I wanted to record the original data, I know that the number 4 appeared once, the number 5 appeared 4 times, and I could continue doing this. 6 appeared twice, 7 appeared once, 8 never, 9 twice, and I could write down the original data set for this as well. Not every graph you'll be able to do this for. Another one that you can recover this for would be a stem plot, which is also called a stem and leaf plot. And again, this represents quantitative data. But what it does is it takes the data and it separates the values into the stem part on the left, and then the leaf part on the right. So when we look at this data, the way to read this is a 5 followed by a 3 and a 9 means that we have 2 data points. One is going to be 53, and one is going to be 59. And just so you're aware, this is the same list of numbers that was in the video a couple of videos ago. So we can recover each number from our list. So we have 62 and 67 are the only numbers in the 60s. 70, 74, 74, 76, and 76 are all the numbers that appear in the 70s, and so on and so forth. So you can just read off every single number in this list. Quite often, the stem part is going to be the first few digits of a number, and the leaf part is maybe the last digit, or maybe the last 2 digits of the number. Again, this displays shape rather well, so we can kind of see that there's fewer numbers in the 50s and 60s, a lot in the 80s, and then some in the 70s and 90s as well. You can recover the original data. Again, I could just list every single number that appears in this data set, and moreover, it's sorted for me. One important thing is that the leaves should appear in ascending order, going from left to right. So this does display a lot of information. It's maybe not the prettiest, but the data is right there for you to read. Next, we have a time series graph, and for a time series graph, as the name implies, this is for data that's collected at different points in time. So here I looked up some data on the average number of sunspots on the sun in any given year. So here the data points will be arranged by year, going from 2000, beyond 2010, and for each year plotted in blue, and I hope this shows up what the average number of sunspots was for that year. This helps you see trends over time. This doesn't have to be year by year. Time series graph could be anything from month to month, day by day, minute by minute. So there's lots of different uses for this. But the main reason that you would do this is if something is changing over time and we want to see how it changes over time. This is going to be one of the most useful types of graphs. The next one are bar graphs, And bar graphs are very similar to histograms, where you use a bar to represent how many things belong to a particular category. Bar graphs, bar charts, and histograms are not quite the same thing. Histograms, the bars must touch, whereas in a bar graph, they don't have to, but they can. And normally with a histogram, you are looking at the categories that things belong to are in fact ranges. And bar graphs are more commonly associated with just explicit categories rather than ranges of data points. But they are very, very similar. And a very particular type of bar graph is called a Pareto chart. And we'll compare this to another type of chart in a second, but essentially it's a bar graph that's been arranged in decreasing order. So here I'm teaching 3 courses this semester, and I have the enrollment in each of my courses graphed here. So in one of my courses I have 20 students, in another one 18, and then the last one 11 students. So you can see the relative amount of students in each one. This course has about half as many as the other courses, so it does show relative frequencies. And by arranging it in decreasing order, it highlights the important data. So in particular, if there were many more categories here, the first several would be the ones with the most things in it, the highest frequency. The ones furthest to the right are going to be the ones with the fewest things in that category, the lowest frequency. So it's easier to identify which ones have the most and which ones have the least when they're arranged in order. Now I want to compare a Pareto chart to a pie chart. And essentially the goal here is to convince you that pie charts are bad. So again, with a pie chart, you take a circle and you divide up the area essentially into slices, where each slice is proportional to the relative frequency. So for instance, in the previous chart, this course had 11 students in it, and I would want to create a slice whose angle right here is going to be proportional to 11 over the total number of students in all the courses. So when we look at this, we have to do a couple of steps in our head to really understand what's going on. We have to see how big this slice is and compare it to the other slices just visually, because it's harder to compare areas than it is to just compare the height of several things. But also we can't recover any of the original data from this. And pie charts are just worse in pretty much every way than Pareto charts. I think the only time that I could think of is if you had 100 different categories and a lot of them were too tiny. In a Pareto chart, that would be really long. In a pie chart, you can just squeeze them in as really tiny slices. Outside of that, a Pareto chart should be used every time, more so than a pie chart. And the last one that I'll mention is a frequency polygon. And essentially, a frequency polygon is a histogram in disguise. So for me, to explain this, what I'll do is I'll just start with a histogram here. And this is the same histogram that we've been looking at for a couple of videos now, where it's the made-up test scores from a course. And the idea is that I have the histogram here. So between 49.5 and 59.5, we had two data points. In the next range, we had 2 data points, and so on and so forth. Frequency polygon, we're going to, instead of worrying about the endpoints, we're going to label these with the midpoints. So here, I'm just going to call this, so this will be, excuse me, this is 54.5. 64 and a half, should be a 4. We've got 74 and a half, 84 and a half, and 94 and a half. So each one of these is just the midpoint of the range. And then furthermore, what we'll do is we'll draw a dot at the top of that range, right above the midpoint. So we will erase this and instead draw some dots instead above the midpoint in each one, and we will connect them with lines. This is the frequency polygon, and it shows you the rough shape of the data. So this is quite nice. And one reason why we might use a frequency polygon instead of a histogram, I think histograms look a little bit nicer, but a frequency polygon is just this little line here, and it's not filled up with a lot of bars. So if we wanted to, we could combine several frequency polygons into the same chart and be able to compare these a little bit easier. We don't have all sorts of bars that are overlapping now. We just have this line that we can trace, and we can see multiple ones. There is an example of this in the textbook that I would recommend that you look at. And we'll stop here, and I'll talk about more bad things in graphs in the next video.